All right, this is a video for geometry for assignment 11. Last assignment we did the trig ratios. This one we're going to be using those trig ratios to find parts of right triangles. I'm going to go through this extremely quickly because I want to do some examples at the end and I want to spend most of the time on that. So follow along. I'm going to go back over some of the stuff real quick and then go over a couple of new things. SOHCAHTOA, remember, write this down each time. SOHCAHTOA, the S stands for sine, and on your calculator it's SIN, and that's the opposite leg over the hypotenuse. C stands for cosine, that's COS on your calculator, and that's the adjacent leg over the hypotenuse. T stands for the tangent, and it's TAN on your calculator, and that's the opposite leg over the adjacent leg. You've got to know this every single time for all these problems that we're going to do. SOHCAHTOA. These are the equations. We're going to be setting up these equations each time. Each one of these equations has three parts. It has an angle, and it has two of the sides. You're going to know two of those three, and we'll be finding the third. So sometimes you'll be trying to find the angle, and you'll know these two parts. Other times you'll be trying to find maybe the adjacent leg, and you'll know the angle and the hypotenuse. But each time, and you're going to set up one of these equations every single time. When we do this, remember, first thing you got to do is you got to label your triangle. We pick an angle. So if I pick angle A, we got to label this, the opposite leg. That's the side across from the angle that we picked. The hypotenuse is always across from the right angle. And then the third side is the adjacent leg. You've got to label these every single time, otherwise you get lost. The other thing I'm going to say right here, if we have a picture like this, some things that we do in geometry and in math, notice angle C I make as the right angle, because a lot of times we just want to be uniform. And remember, Pythagorean's theorem is a squared plus b squared equals c squared. These are little letters. Well, in geometry, what we do a lot, if you have to draw the picture yourself, or just to save time, is when we label a triangle, the angles are capital letters. So it might be angle A, angle B, and C, and usually C, if it's in the triangle, is the right angle, so that it fits with Pythagorean's theorem. Then the sides across from those angles are the lowercase letters. So if this is big A, capital A right here, the side across from it is little a. The side across from big B is little b. And the side across from big C is little c. So this is just so everybody is uniform, everybody's on the same page. If we have a right triangle, and it doesn't necessarily have to be a right triangle, could be just about any kind of triangle. If we have something like R, Q, and D, the side across from angle R or big R is little r. Side across from Q here would be labeled little q, and the side across from big D is little d. Just a way to try to keep everybody on the same page, everybody uniform with everybody else. Sometimes when you have to draw the triangles yourself. We went over this part last time. If you're just finding the sine, cosine, or tangent of an angle, which we're not going to be doing this time, then you use one of these two processes. This is all stuff we covered last time, so I'm not going back over any of this. A couple of things to remember. Sine and cosine always got to be less than 1. What I mean by that is it's always got to be something like 0.2, 3, 4, 5. If you have a number out in front of this and you're dealing with sine or cosine, then you did something wrong or your calculator's not set up right. Tangent can be any number, so it could be like 17.2834. It's all right to have something bigger than 1, but for sine and cosine, it's not. On some of you, if you're having trouble with your calculators, if it's not giving you the correct answer, it's because it's not set up correctly. On the big calculators, the Texas Instruments or the TI 83 or 84s, remember you're going to go to your mode, find the mode button, and the third line down, once you push that mode button, is going to say radians and degrees. You want to scroll over to degrees, and that's what you wanted. If you're on one of the small calculators, your screen looks like this. It should say DEG on it somewhere. That means it's in degrees. If not, then you need to go to, on the TI 30s, you have a button on there, it's a DRG. You go to it, and it'll pop up. Degrees, radians, gradians. You want the degrees to be underlined. If it's not that, or the mode's wrong on it, if it's not in degrees, then it's going to give you the wrong answer. For the Casios, I'm trying to remember what it was on the Casios. On the Casios, you have to hit the shift button, then you go over and hit the mode button. And you go in there, go into that mode screen, and it says degrees. You scroll down to it and you hit enter, and it'll put it on degrees. So make sure that it's in degrees. If you're getting answers like this, if you do the sine of some angle and it comes up 3.6285, then something's wrong, because sine should not be more than 1. If you're getting answers that are negatives, now there's some answers that are negatives for sine and cosine and tangent, but most of the ones that we're going to do are not. So if you're getting something like negative 7 or 0.7632, then something's probably wrong. It's not set up in the right position. It needs to be in that degrees. If it's not in degrees, none of this stuff, the rest of this chapter, you're going to be able to do correctly. So make sure your calculator is right. If it's not, call me. If you're not sure, call me, email me, and my number's right there at the top of Moodle. Call and I'll help you fix it. Another thing to know, a lot of times, instead of using just the letters like angle A, a lot of times in geometry we'll use Greek letters to stand for an angle. So if you see something like this, that's just like a variable. It's just like having an X in there. So if that confuses you and you don't like having that Greek letter in there, change it, make it an X. I don't care. That's just what you're looking for. These are the main Greek letters that we use to stand for angles. This first one's an alpha. This is a theta. This is a beta. Those are the main ones that we use to stand for different angles. I think on one of the videos I called this the wrong thing. It's a theta. I can't remember what I called it, but it seems like I called it by the wrong name. So alpha, theta, beta, they just are variables to stand for angles. Steps. These next 3 slides, very, very important. I'm going to go through them quickly so I can do the examples. Each time, you've got to do all 4 of these things. You're going to pick an angle. If we're looking for an angle, then that's going to be the angle you pick. If they tell us an angle, not the right angle, then we're going to pick that angle probably. Label the triangle, opposite, hypotenuse, adjacent. You got to do that every time. Then you're going to write an equation. That equation's got 4 parts. First part, the trig name, sine, cosine, or tangent. That's probably the hardest part, is deciding which one you're using. Second thing is your angle. The third thing is the equal sign. And then the fourth thing is your ratio. And that's just going to be some fraction. Something like 5 over x or whatever it happens to be. So every single time, trig name, then the angle, equal sign, then the ratio. Then you're going to solve that equation. Now I'm going to show you how to solve those equations. So every single time you got to do these 4 steps. If you're trying to find a side in a triangle, these are the 10 steps to find a side in the triangle. You pick your angle, just like we said on the last one. Label the triangle, opposite, adjacent, and hypotenuse, according to the angle you picked. I should go back to number 1. You can't pick the right angle. It's got to be one of the 2 acute angles. Then, this is probably the hardest one. You've got to decide, or I shouldn't say it's hard, it's the one that most students have the most trouble with. You've got to decide, am I using sine, am I using cosine, am I using tangent? The way you decide that is by the information you're given and what you're trying to find. One of the sides and one of the angles, most of the time, you're probably not going to care about, so you just ignore them. Set up your equation just like on that last slide. Then, once you have your equation set up, you're going to push sine, cosine, or tangent, whichever one you picked, or whichever one you know you're using for that problem. I shouldn't say pick, because it's not a choice. Whichever one that you had to use because of the parts you are dealing with. Put in the angle that you picked. That was the angle that they probably told you. Push enter equals. I know a lot of this doesn't make sense now, but it will as we go through the problems. You're going to write down your answer. So you start off and you say, okay, I'm using cosine this time. I'm going to get rid of that. I'm using cosine this time. The angle they told me was 38 degrees. And they cosine deals with adjacent over hypotenuse. Well, the adjacent side was 17. The hypotenuse was x. Notice here we know 2 numbers, and then we have a variable. So our equation looks like this. Next thing you got to do, and what you're doing in this step, or in these steps, you're using your calculator and you're getting rid of the word. Get rid of the word. Sine, cosine, or tangent. You can't solve an equation that's got sine, cosine, or tangent in it. So we're punching this into our calculator, and it's going to tell us something. And I'll actually punch it into my calculator here so I don't mess anybody up. We punch in cosine 38, it equals, and it tells me 0.7880. So now my equation looks like this. It's got a decimal on this side, equals 17 over x on the other side. Next thing, take this decimal part and you put a 1 under. The reason we do that is so that we have a proportion and it's easier to solve. So every time you find that decimal, then you just put a 1 under. The next thing we're going to do is we're going to cross multiply. That number times x going that direction equals 1 times 17 is just 17. So we cross multiply and we solve it. Divide both sides. Sometimes you won't have to do this step. Sometimes it'll already have x by itself. This time we have to divide both sides by that number, and it's going to leave us with x equals whatever our answer is there. That answer is the length of the side. Normally the length of the side, we'll round it off to the nearest tenth. So you go out one place behind the decimal. For angles, which is on the next slide, we'll probably round them off to the nearest whole number. If you round them all off to the nearest tenth, I won't throw a big fit. But a lot of times for angles, we just round off to the nearest whole number. So that's no places behind the decimal. So you do those 10 steps. That's to find a side. To find an angle is a little easier. because your calculator is going to do most of the work for you. So on this, you pick an angle, it's the one you're trying to find, that's one you want to pick. You don't want to pick the other one and do extra work. Label the triangle, decide if you're using sine, cosine, or tangent, set up your equation just like on the others, and once you have it, it's going to look something like this. Tangent of, I'm going to use theta as our angle. So tangent of theta, that's what we're looking for. If you don't like that, then you could make it tangent of x or whatever the angle is, tangent of angle A. I don't care what your variable is there, makes no difference, equals, and then if it's tangent, it's going to be opposite, whatever the length of the opposite leg is, over the length of the adjacent leg. And we're going to know these two, so it's going to look something more like this. Tangent of theta equals 5/12. Once you have that equation set up, that's right there on your calculator. Since we're looking for an angle, you're going to use that second button on your calculator, or the shift button, depending on which calculator you have. So you push second, push the trig ratio that you picked. This time we picked tangent, so I'm going to push that. So I'd hit second, tangent. Then I just put in this fraction. When you do all this, you hit second, then tangent. Your calculator is going to look like this. Tangent, -1. That's telling the calculator, hey, we don't know the angle this time. We're looking for the angle. So the calculator is going to know to do the inverse. And then it'll have a parenthesis there. And then you just put in 5 divided by 12, close the parenthesis, and then you hit enter or equals, and it will tell you the answer. And you round it off. If it comes up in like 32.3, something, 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 and it just keeps going, then we're going to round that off to 32 degrees. So the calculator is going to do most of the work. You got to set up the equation, then you're just going to punch it in the calculator. When you're looking for an angle, got to remember that you're hitting second. You're going to use the second button or the shift button. Angle of elevation, angle of depression, angle of elevation, going up. So we're looking straight out here and we look up, that's an angle of elevation. Angle of depression, going down. We're looking straight out here and we look down at something, that's an angle of depression. Just some things, so I'm going to go on to this next slide. So if I'm standing here, I look straight out, that's my horizontal line of sight. Then I look down at something, so there's something down here that caught my eye, look down at it. This angle right here is an angle of depression. If we finish that triangle out by putting in that third side, we now have a right triangle, and we can use Pythagorean's theorem, a squared plus b squared equals c squared, or the trig stuff, or any of the other stuff that we learned about right triangles to find missing parts in that triangle. So that's an angle of depression. They might tell you something like, you're standing on a cliff and you look down at a boat and your angle of depression is 38 degrees. Well, that's telling you that that angle right there is 38 degrees. Next one, angle of elevation. I'm standing here. I look straight out. That's my horizontal line of sight. Then something up here catches my eye. So I look up at it. That's an angle of elevation. I finish out the right triangle. And we can use the trig stuff or any of that other stuff to solve for a missing part in that triangle, whatever part maybe we're looking at or trying to find. On your calculators, remember on your calculators, don't forget where the second button is. Remember, you're only going to use it if you're trying to find an angle. Make sure you know where the sine, cosine, and tangent are on the calculator if you're using one of these small calculators. The other thing to remember on this calculator, this button right here, that's the DRG button. If you click on it, it says DEG, RAD, GRD. You want that to be underlined. It's got to be in degrees. That stands for degrees. It's got to be in that. You look right down here at the bottom of the screen, and it should, right there, it should say DEG if it's in degrees. If it's not, it's going to be giving you the wrong answers. So if you're doing stuff, if you're doing any of these problems, and you hit the button and it says the sine of some angle is negative 0.3286, if it's got that negative in there, it's probably messing up, and you need to get a hold of me and we'll fix it, or figure out how to fix it on your own. But it's got to be doing degrees. Next one on this calculator, you need to remember where the second button is. Again, remember you only need it if you're trying to find an angle, sine, cosine, and tangent. Then this mode button right here. If you click on that mode button, you go down to the third line, and on that third line it says radians, and it says degrees. You want the degrees to sort of be blackened in, or whatever it is on your calculator. So you got to scroll over to it and make sure it's in degrees. All right, we're going to do these problems together. These first three, you're finding a side. Things I need to remember here. SOHCAHTOA. Sorry, my pen's not working very well. And I need to remember the trig name, what our equation is. Trig name, the angle, equals, and then the fraction. Every single time. First thing you're going to do, you're finding a side. We know we're finding a side because it has an X right there. Pick the angle that you want to deal with. Always deal with the angle that they tell you. We could find this angle, but no reason to find it if they've already told us this one, and we can just use it. Never ever are you going to use the right angle. Never. So we're using this angle, then we're going to label our triangle according to that angle. Side across from it's the opposite leg. Side across from the right angle is the hypotenuse, and then the other side is the adjacent leg. You've got to label your triangle every single time. Opposite, adjacent, hypotenuse, every time. Now here's the hard part. You're going to set up your equation. When you set up this equation, you got to decide which sides do you care about and which side do you not care about. Or which angle do you care about and which angle do you not care about. This time, we're looking for the opposite leg, and they tell us the hypotenuse. We don't know anything about the adjacent leg, and we don't care to find it, so we're just going to get rid of it. So all we care about is the opposite and the hypotenuse. That's going to tell you which trig ratio you're using. All right, so the opposite and the hypotenuse, we look up here at our SOHCAHTOA. We look at SOHCAHTOA right there. Opposite and hypotenuse is the sine. So when we set up our equation, first thing we're going to write down is SIN, the sine. So that's the trig name. Then we're going to put in the angle that we picked, which was 25 degrees, equals, then the ratio. Well, the SO part here, the sine, SO part, sine is opposite over hypotenuse. Well, the opposite this time is x. The hypotenuse is 62. That's our equation. Next thing we're going to do is we're going to grab our calculator, and we want to get rid of this word. We can't solve this problem if it's got a word in it. So you just grab your calculator, and all you do is you hit sine 25. Don't hit second. We're not looking for the angle. We know the angle this time. and then you just write that down, 0.4226. Always go out 4 decimal places. And that still equals x over 62. I didn't change that other side yet. Next thing we do, on this decimal side, we put a 1 underneath it. We make it into a proportion. Then we cross multiply. 1 times x is just x. This is one of the nice problems because we do one step and x is by itself. That's going to be our answer. We multiply this way, take your calculator and punch in 0.4226 times 62, and you end up with 26.2012. Normally on sides we're going to round off to the nearest tenth. Well, that's right here. That's one place behind the decimal. That 0 tells us leave the 2 the same, so we're just going to get rid of that. And that means the length of our side that we were looking for is about 26.2. So the length of this side right here should be about 26.2. Next one. Pick the angle. Well, we're going to pick this angle because that's one they told us. That's your opposite. We're going to label the triangle. That's your hypotenuse. Side over here is your adjacent. We're looking for the hypotenuse. They told us the opposite. Again, we really don't care about the adjacent this time, so we're just sort of going to ignore it. Then we're going to set up our equation. Hypotenuse and opposite. We look back up here at our SOHCAHTOA. Opposite and hypotenuse is the sine again. So we do sine of our angle. When we're setting up our equation, the trig name, the angle, 38, then the equal sign, and then the fraction. Well, the fraction this time, since it's a sine SOHCAHTOA, is the so part, it's the opposite over the hypotenuse. So the opposite leg, 21, over the hypotenuse, which is x. We grab our calculators and we figure out what the sine of 38 is. Just punch in sine 38 and you come up with 0.6157. Go out 4 places again every time when you're doing sine, cosine, or tangent. Still equals 21 over x. Put a 1 underneath this. And then we're going to cross multiply. 0.6157 times x equals, cross multiply that way, is 21. Now this one, unlike this first one, this one we have an extra step. X isn't by itself, so we got to divide both sides by 0.6157. These cancel out. You're left with just x on that side. What you need to remember over here is every time you divide a number by something less than 1, your number should get bigger. So when we divide this, our answer should be bigger than 21. 21 divided by 0.6157, and I end up with about 34.1. You can always go up and make sure that your answer makes sense. If we put it in here, that's the hypotenuse is 34.1. Remember, the hypotenuse has to be the longest side. Is that 34.1 longer than the side that they told us? And yes, it is, so then that would make sense. The next one, going a little quicker here. We're picking this angle. That's going to be the opposite leg. That's the hypotenuse. This is the adjacent. Labeling the triangle every single time. We look at what we know and what we're going to use. Well, this time we're not going to use the opposite. We don't care about it, so I'm just sort of going to get rid of it. We're dealing with the adjacent and the hypotenuse. We look back up here at SOHCAHTOA and figure out which one deals with adjacent and hypotenuse, and that's the cosine here. So our trig ratio is going to be the cosine of our angle that we picked, 39, equals, every time, name, sine, cosine, or tangent, the angle, equals, and then the fraction. This time it's for the part, it's adjacent over hypotenuse. So adjacent, which is 3, over the hypotenuse, which is x. We grab our calculator, and this time we punch in cosine of 39. Cosine of 39, and I get 0.7771. That still equals 3 over x. Put a 1 underneath that. Cross multiply, I get 0.7771x equals 3. And after you see the pattern on these for a while, you can probably do a bunch of this in your calculator. You don't have to write everything out. Divide both sides by 0.7771. Remember, your answer when you're dividing by that number should get bigger. We end up with x equals, punch in your calculator, 3 divided by 0.7771. And I end up with about 3.9 when I round it off. So the length of this hypotenuse right here is about 3.9. Should be the longest side. We look here, compare it. Yes, it's longer than that. That's how you find a side. Finding angles. Find an angle in a right triangle. So this is finding angles. Again, some of the stuff we gotta remember the SOHCAHTOA. I'm gonna write that up here. We also need to remember the equation that we're gonna write down each time, which is the trig name, the angle, equals, and then the fraction. Notice on each of these, the angle that we're looking for, they've labeled with theta. Don't let that confuse you. If it does, then just change it to an x or whatever. On this first one, I'm dealing with this angle, side across from that. Now, the reason I know that we're dealing with this angle, that's the angle we're looking for. And by the way, these should be easier. And you're finding an angle should be easier because your calculator is going to do most of the work for you. But we know we're looking for this angle, so that's the angle we're going to pick. Label it opposite side. Side across from the right angle is the hypotenuse. Side over here is the adjacent side. Figure out which sides you really care about and which sides you don't care about. This time, we really don't care about the hypotenuse. They didn't ask us to find it, and they didn't tell us it, so we care about the opposite and the adjacent. That's going to tell us which trig ratio we're looking at. We look up here, and we figure out which one deals with opposite and adjacent. Well, it's the TOA part there, so we're using the TOA. And that's the tangent. So tangent of our angle, which we don't know, so that's tangent of theta. Again, you could put an x in there if you don't like theta. Equals, and then our ratio. Tangent's opposite over adjacent. So opposite is 4, adjacent is 13. Now what makes this easier is all we're going to do is grab our calculator now, and the calculator is going to do the rest of the work. Once we have the equation set up, the calculator is going to do everything else. What you do next is on your calculator, you hit the second button, or for some of you, it's the shift button. So we hit second, and then you put in your trig ratio, or the trig name that you're dealing with. This time it's the tangent, so second tangent. And then all we're going to do, your screen, once you hit that second tangent, your screen's going to look something like this. Tangent, -1, that's the inverse of the tangent. It's telling the calculator that we don't know the angle, and we're trying to find it this time, instead of the fact that we know the angle and we want to tell us the sine, cosine, or tangent. So it says tangent -1, and it's got a parenthesis on most of the calculators. And all you do is you type in this, 4 divided by 13, close the parenthesis. So 4 divided by 13, and I end up with 17.1027 something. Most of the time on angles, we will round it off to the nearest whole number. So this 1 right here tells us to leave the 7 alone, and we're just going to say that our angle right there, that theta, equaled 17 degrees. Once we have that angle, we could find this other angle. We could also find the hypotenuse, and that's what we're going to do on the next slide, is find those other parts. Didn't want to erase everything. Oh well. Just have to remember SOHCAHTOA in your formula. Next one, trying to find this angle, so we're going to label the triangle according to that angle. That's your opposite leg. That's your hypotenuse. This is your adjacent leg then. Figure out which ones we actually care about. We really don't care about the opposite leg this time. So we're dealing with the adjacent and the hypotenuse and our SOHCAHTOA. The trig ratio that deals with adjacent and hypotenuse is the cosine, so that's what we're using. So I'm going to write down cosine. Our angle this time is theta equals, then the fraction. Well, cosine is adjacent over hypotenuse. Adjacent is square root of 71. Hypotenuse is 11. Now the one thing I'll say on this one, it's probably going to be a little easier if we go ahead and figure out what the square root of 71 is on our calculator. You can punch it all in at once, and as long as you work it out, but with all the parentheses and everything, it might mess you up. So I come out with about 8 point, I'm going to go out a couple extra spaces, 426. Now all you're going to do on your calculator is you're going to hit second, cosine, and remember your calculator, the screen's going to pull up this. It's going to say cosine -1, parenthesis, and all you're going to do is put in these two numbers divided by the 8.426 divided by 11. So 8.426 divided by 11, close the parenthesis, and I end up with theta equals, and we'll round that off to about 40 degrees. So that angle right there is 40 degrees. Again, if we wanted to find this other angle, angle B over here, we know 3 angles of a triangle got to add up to 180, so that angle would have to be 50 degrees. If we wanted to find this side over here that we don't know, we could use Pythagorean's theorem, we could use sine, cosine, or tangent, one of those, to find it. And that's what we're going to do on the next slide. Next one, we're looking for this angle. That's your opposite leg. That's your hypotenuse. This is your adjacent. The ones we care about this time, opposite and hypotenuse. We really don't care about the adjacent. We look at which trig ratio deals with opposite and hypotenuse. Well, that's the SO part right here, the sine. So we do sine of theta, sine of our angle, equals, this one's opposite over hypotenuse. So it'd be 6 over 9. We grab our calculator, and it's going to do all the rest of the work for us. Tell us what theta equals. We hit second, sine 6 divided by 9, and we end up with 41.81 something, so we'll say about 42 degrees. On on these. It says solve each triangle, and all that means when it says solve each triangle is find all the missing parts. So we're going to find all the missing parts. They didn't label the triangle for us this time, so we're going to do it ourselves. Again, when we label it, A, B, just looking at the names they gave us here, they've got a big A and a little c, so it's probably going to be A, B, and C is going to be the right angle. Angle A is 47 degrees, so I'll write it in there. Little c is going to be across from big C, so this is going to be little c over here. We'll make it 3. This would be little a across from big A over here, and then little b across from big B would be over there. Just so everybody's uniform. Little letters, the lowercase letters, are across from the capital letters. The capital letters stand for your angles, little letters stand for your sides. So we have all that, and we want to find all the missing parts. Well, we're missing measure of angle B, so we're going to find it. We're missing little a, and we're missing little b. We're going to find all 3 of those missing parts. Easiest one to find is angle B, measure of angle B. We know 3 angles of a triangle should add up to 180. So 90 plus 47, that's 137. We subtract that from 180. Grab your calculator and do it, and we end up with the measure of angle B right here is 43 degrees. So that's one of our answers. Even if you can't do anything else, everybody should be able to do that, and you get at least a third of the answer correct. Next, if we want to find, let's just find little a next. Now, this is where it gets a little harder because you got choices. We can either pick the 43 degree angle or the 47 degree angle. I'm going to pick the 47 degree angle here and label the triangle according to that, just like we've been doing. So that's your opposite leg. That's your hypotenuse. This is your adjacent leg. And the reason it's a little tougher here, you got to decide which sides we're actually using. Well, if we're trying to find this side, we want it in there, and then this side we know, so we're going to have it in there. So even though we want to find the adjacent leg at some point, for now we got to find that opposite leg first. So opposite and hypotenuse, that's the sine. So we set up our equation. Sine of our angle, which we picked the 47 degrees, equals opposite, that's A, over the hypotenuse, which is 3. So once we have our equation, now we solve it just like we were doing a couple slides ago. Punch in our calculator, sine 47, not second, because we're not finding the angle. We're just punching in sine 47, so 0.7314 we'll say. We're going to put that over 1. A over 3 still, that's an A. We cross multiply, we end up with A equals, cross multiply that way, just grab your calculator and take 3 times 0.7314, and we end up with something about 2.2 if we round it off. So little a equals about 2.2. So this side right here, 2.2. Several ways we could find little b. We could set up sine, cosine, or tangent again and deal with like adjacent and hypotenuse, which would be the cosine. Or we could use Pythagorean's theorem, and that's what I'm going to do, just to refresh your memory on Pythagorean's theorem. A squared plus b squared equals c squared. Well, A, that's one of the legs, that was 2.2 squared, plus the B, the other leg we don't know, so we'll just leave it b squared, and C is 3, the hypotenuse is 3 this time, so 3 squared. If I'm doing this, I grab my calculator, and I do the 3 squared, which is 9. And then I know I'm going to subtract this part off, the 2.2 squared. So just put in minus 2.2 squared. And we end up with all this other stuff going, we end up with just b squared equals 4.16. Well, then you got to take the square root of both sides. That's going to leave us with b equals, so we just punch in second square root, 4.16, and I end up with about 2.0. So little b equals about 2.0, and we found all the missing parts in that triangle. I'm going to skip this last one. I will label it real quick. Just if we go A, B, C, little a would be over here, that's 7. Little c would be over here, that's 25. If you remember, one of the Pythagorean triples that we talked about was 7, 24, 25, where the 25 is the hypotenuse. And that's what this is. So this side over here would have to be 24. We could do Pythagorean's theorem to find that. So we know that's little b. I'll just go ahead and do it now. Little b is 24. We still need to find the measure of angle A and the measure of angle B. Well, the way we can do that is just what we've been doing. If we pick one of them, I'm going to pick angle A. Well, you can write theta or x or whatever you want in there, stand for angle A, or you can just leave it angle A. And we label the triangle. That's the opposite. That's the hypotenuse. This is the adjacent. I'm going to pick these two this time. We know all three sides, so it doesn't really matter which ones we pick. I'm going to pick those two, opposite and hypotenuse. That tells me I'm using the sine of our angle that we're looking for, which we call x or a or theta or whatever you want to call it. And since it's sine, that's the so part of SOHCAHTOA. It's opposite over hypotenuse, so 7 over 25. And then your calculator is going to do all this for you. Hit second, sine 7 divided by 25, it equals, and it comes out that x equals about, we'll say about 16 degrees. So that's angle A. Angle A is 16 degrees. If we know angle A is 16, that we could go back and do the same thing to find angle B, use sine, cosine, or tangent. Easiest way though is just to take 90 plus 16, that's 106, and then subtract that from 180 because the three angles of a triangle have to add up to 180, and that tells us angle B up there has to be 74 degrees. So we found all three missing parts of that right triangle.